Yeah, hi everybody. My name is Vitali Henne. Usually my colleague should have held this talk, but he fell ill shortly, so I'm filling in. I'm working as a full-stack developer for Freiheit.com. We just opened an office in Lisbon, so if you're curious what we do, just check us out. We are always looking for new talent. Right, so and the idea of this talk is like, we've been using Kubernetes for more than 3 years now, so we're like one of the early adapters. And we have currently more than 240 deployments in production and more than 650 pods running Kubernetes. And if our team looks back through the 3 years, I would say that it's like one of the few choices which we never regret. So we were very happy that we choose Kubernetes. And the idea of this talk is like to talk what we did wrong in the past, and hopefully you don't make these mistakes, right? So one of the big promises of Kubernetes is you can do zero downtime deployment. So you can deploy, and the customer doesn't really realize that you deployed new software, right? And one way how Kubernetes achieves this is like with readiness probes. So every service can say, hey, I'm ready. Please route some traffic to me. So it's basically just a REST endpoint, which Kubernetes will poll periodically, and if it returns to 100, then the service will receive traffic. And also during rolling updates, newer services which are being started only receive new traffic if they actually are healthy, and old ones are only shut down if newer ones are healthy. So seems good, right? And in theory, it's really good because it's cool during deployment. It's very cool for temporary glitches. So imagine, like, I don't know, I have some glitch in the network connection and I can't answer requests. Then I'm not ready or healthy. And as soon as it's over, I get new traffic and everything's cool, right? But the problem is if you have a real problem, so like, I don't know, the database is burning and you're therefore not ready, then all of your services are not ready, and then Kubernetes won't just route any traffic to you, right? Because no pod is ready and it's like, yeah, you have downtime. Not cool. And the way to solve it is with liveness probes. So you can define another probe, which is also polled periodically, and as long as this probe returns to 100 or healthy, the pod is considered healthy, and as soon as it's like a 500 on error, the pod is killed and restarted. So pretty good. Also, Kubernetes has this concept of limits, so you can say for each service how much resources it can use. It can be both CPU limits and memory limits. And if the service uses too much, it gets either killed, so if it uses too much memory, it's just being killed by Kubernetes, or in case of CPU resources, it's just being throttled down. So in theory, liveness probes plus CPU limits, and we're happy, right? So everything should work out as expected. Well, sadly no. So what happens if actually your CPU limits are violated? So in that case, Kubernetes will throttle your service down, so you won't get that much computing power. And it quite often happens that a service on startup requires a lot more resources than during runtime. So if you just look at your metrics and you see, yeah, my service only needs like 15 milli-CPUs, and I just give him 100 milli-CPUs, everything should be fine. But it may be very possible that during startup, the service needs, well, I don't know, like 1 CPU or something. And then you have like this vicious cycle. So the service is throttled at startup. The service can't really answer the liveness probe in time because it's being throttled. Then the service is being killed because Kubernetes thinks the service is not healthy anymore, and then you rinse and repeat. And then you have like failing, cascading failures. So, and the idea why we actually introduce these CPU limits is that we do not want nodes to be overcommitted. That is, we do not want services to compete for resources, because otherwise it's very opaque to understand actually why your system is going down, right? Because you may have 2 services, both need a lot of memory and a lot of CPU, but you don't have that much computing power at the actual node. So this is like the solution why, or the idea why Kubernetes allows you to set limits. So now we have a new problem. How do we set the correct limits? If you're using like Java, and modern Java, you can use these settings from the GVM 1.10 use container support, or before that, experimental VM options and that. But before that, you need to do it actually manually. And the problem is that you can set the heap space, but there's also like off-heap memory, which is also considered against the Kubernetes limit, but not with the settings. So it may very well be that you are completely free on the heap, but your service is still being killed because your off-heap memory is that large. Another problem. So what happens if things fail and pods die? Right? So your readiness probes usually uses health endpoints, and the service should know best. So you're like saying, yeah, well, I should not depend on other services, but at least the database connection should be there, right? So imagine you have 3 replicas and 200 services and 1 check per second, and now you're just firing 600 requests per second onto your database just to check if you're healthy, which is a lot of load for an idle system. So also, don't do that. Or scenario 5. Imagine you have a service which needs 5 minutes to boot up, right? No problem, you have running updates, so continuous integration, everything's fine. And the health check only depends if the database is actually there. It's also fine, right? So if if your connection drops, it may be a very complicated driver, so you just restart the servers, everything's fine. But now you have a glitch in the network connection, and suddenly the database doesn't answer for 30 seconds anymore, or timeouts. And what happens? All your services are being killed because they can't answer readiness probe, and it takes them 5 minutes to boot up. And now you've earned 5 minutes of downtime. So also. Yeah, and the last one. So there's also this concept of multi-processor support container. Like 1 year ago, so we use Alpine as our base Linux image for all our services. And 1 year ago, the DNS in Alpine was very bad. So it wasn't really compatible with the Kubernetes DNS. So our solution was to ship our own DNS server. But now you have like 2 processors which you need to monitor, right? Because if either one of those fails, your service is down. And the solution would be like to introduce a supervisor service or supervisor init system, which supervises those. But now you have like a third problem because you need to monitor the supervisor system. Yeah, that's it.